Hi everyone, Avi. This is me, Avi. Hi everyone, say hi in the chat because today is Saturday, so we'll have another live event. And today it will be an incredible episode because we will talk about AI, Docker, Rust. I don't know, all my favorite topics in the same live event. To do this, it took me some time, but I finally managed to have two, not one, but two amazing guests. So I would really love everyone to make some noise now that we are here, Julia and Avi. And let's get started. So let's go. And I want to invite them both at the same time. So welcome, Michael, and welcome, Marco. So hi,
So,
how are
hi,
you?
hi
How's it
everyone.
going? Yes, so I wanted to do this live stream since October. So it took me a while to organize and think when, but I've been a bit busy, and now finally this is happening in on my channel. So I would love everyone to drop a hi, hello, where are you from? And I would love Michael and Marco to introduce themselves. I think this will be very interesting because we'll also have, we'll mess up, and there might be a demo at some point. I want to show you a 5-second sneak peek. So this is what you will have at some point during this live event. So stay until the end. Hey, Julia, Avi, Pratyush, perfect. So Michael, please introduce yourself and welcome. So happy to have you here on my channel.
All right, thank you, Francisco. And my name is Michael Yuan, and uh, I started open source many years ago. My first project. Some of you, if you're old enough, you may remember. It's a project called JBoss. It's one of the first open source Java application server. So I started in Java, and I like to tell people I get into open source because I have no choice. I have a PhD in astrophysics, and after I graduate, my wife, who also have a PhD in business management, she wants me to find an industry job so we can better support the family. So I said, well, how hard it can be, my just to find a programmer job, and then I interviewed with a bunch of places, and they said we can't hire you, in particular Microsoft at the time. I interviewed with them for a long time, and they said, first, you have a PhD, you are overqualified, your salary is too high, and second, you really don't know how to program. So I was very pissed. So I decided I want to join the software development movement without a gatekeeper, and that's open source, right? So that's how I started in open source all those years ago. And the first project, Get Lucky, we sold to Red Hat, and I stayed in Red Hat for a couple of years. And then after that, I started my second company and third company. That's some of them successful, some of them not. So I have always been, trying to find new ways to do open source and trying to find new business model to open source. So over the years, I have invested in open source as an investor. I also have a company called Second State. We used to focus on WebAssembly, WebAssembly runtime. And in that area, we get introduced to Rust because Rust is closely associated. It's like JVM to Java. WebAssembly is a runtime for Rust. That's how we like to see it. But with AI coming along, and there's lots of ways, new ways to write software, and also I thought it's very interesting that AI has basically changed the whole business model of software as well, because it's now because the expense of AI is in hosting the model. It's very expensive to host the model and provide services, not in developing the model itself. So that changes how the traditional open source software model makes money, right? So that's gets us to think new AI projects. So that's why we created a project called Echokit. You probably have seen a lot of AI focused hardware and things like that. Almost now it's open source because they all want to tie to a specific backend and things like that. So we try to make it open source, and then naturally we write it in Rust so that we can take advantage of the modern programming language and all that. So yeah, that's long-winded way to introduce myself. That's nice to meet you all.
That's amazing, and it's basically filling my heart because we are also both Docker captains. You're talking about Rust and WASM. I had a talk about Rust and web development that I will redo after this. So whatever. So this is perfect. I'm not much into the embedded systems, so this is also why I wanted to do this live event. So I want to explore more. For sure, I tried out. No, we will show it. We'll show it later. Maybe I would like Michael to have the honor to show it on the screen at some point. I would like everyone to say hi and also let me know if you have ever had some experience in embedded systems, and what you're using. Okay, so. And now I would like to introduce my dear fellow Docker Italian Docker captain Italian friend, Marco. Marco, we know we are not that close to each other as people might think, and this really makes me sad, but still we are for sure probably closer than Michael. So
sure.
Marco, please introduce yourself. It has been a pleasure to meet, by the way, both of you in Turkey. Three months ago.
3 months ago.
Wow. Yeah. So, Marco, please introduce yourself and welcome on my YouTube channel.
Yeah, thank you very much for having me here. So, hi, everybody. I'm Marco. I'm a Docker captain, as Francesco said, since 2023. But we met just 3 months ago in Istanbul. It's quite funny because we are both Italian, but we met in Istanbul. I'm a software developer. I am not on the Rust side. I am on the Python side, but maybe Francesco will change my mind. I don't know.
Nobody's perfect. It's fine.
I really love make project with hardware. So I'm here for the hardware side. I love embedded system. I like to play with, especially ESP32. So I have a lot of questions for Michael about that. Welcome everybody, and I think we can start talking on the real meat.
Perfect. Before that, now I want to drop a very biased poll. What do you think is better, Python or Rust? I'm not sure which one will win on this channel, but I want to give at least the Python developers a chance. So I will drop this here. Let's see how it goes. And yes, so this morning I shared a picture of this thing, I would say, and it was intentionally not clear. Like people started to say, "What is this? What is that?" So this was intentional, of course. And now I would love Michael to talk more about this, and maybe at some point, I don't know, even show some stuff. I think a great advantage of doing hardware stuff is that you can actually touch things. It's like my book. I'm not touching. I'm not showing it now, but it's an advantage, in this AI and software world, having something physical. It's a different approach, so that's very interesting. So, Michael, please introduce us to the core idea of this project. I'm super excited, and yes, maybe at some point we might even have a nice demo. So, Michael, please, over to you.
Yeah, so I'll save the demo to the last, or later part of the show, so that you guys can stick around and, right, So, like I said, there's in the embedded space, the software is traditionally written in C++, and the backend is also is often, because a lot of those devices now have a server attached to it, right? We're going to talk about that in a minute, because if you go to CES today, this year, for instance, the big consumer electronic conference in Las Vegas, right? You see a ton of what they call AI toys or AI companion. Meaning those are a teddy bear, for instance, and it can talk to you, it can tell you story, it can help you learn English, it can do all kinds of things. It can do psychological counseling, whatever. That's those devices seem to gaining bigger and bigger market share, or people are starting to accept it, right? Especially younger people. So however, like traditional hardware space, when you look at so there are actually two ways of thinking about this. One is people might think, okay, the AI is embedded in that device. Okay, so when I talk to the device, it's actually the device talking back to me. But in 99% of the time, it's not the case, right? Because we know the large language model cannot run on a hardware that is, say, less than $5,000 US. It's the hardware inside the device is typically way too small for a competitive large language model to run in there. Although there are, smaller large language model like, I'd say Tianwen 0.6 billion parameter model, things like that. The model itself is half a gigabyte, so it's possible that you can fit that into a Raspberry Pi and run it in those devices, but it's a stretch, and it's also, when you consider the memory and the power consumption and all that, it's not great. So most of those devices are set up to connect to Wi-Fi and have a server behind it, right? So you talk to it, and then it goes to the server to get a response. So now the challenge becomes, how do you super optimize the whole process so that on the device you only have the microphone, the Wi-Fi, and the speaker, and everything else is handled on the server. However, the transmission and the response time can still be controlled, say under 1 second, or at least 2-3 seconds at most, right? So that's becomes a challenge, and that's also goes beyond what traditional embedded software developer are used to. So for instance, if you are, say, in the traditional embedded software, say you are developing software for the car or for home automation and things like that, a lot of them are mostly focused on manipulating the device itself, not much about the server. So now the embedded device developers, increasingly, they need to be full stack. They need to understand the server. That means, the old way, or I would, the old way of using C, C++, or even assembly language that runs directly on the device is I wouldn't say it's getting outdated, but with more, you need a more complete skill set to develop those complete solutions. Otherwise, instead of hiring one developer, you need to hire 2 developers on your team, right? So it's so I think there's the developing landscape on the embedded side is definitely changing because the introduction of the server, right? And on the other end is traditionally those embedded devices are written in C, C++, but as we all know, or as I think it's getting to be the consensus now, is that a lot of C, C++ software, at least in the application space, should be rewritten in Rust because it's just safer, and also it's a lot it's a lot more reliable. So but that's because this conversation is about AI embedded and Rust, right? So I also want to add, in the past maybe 10 years, the biggest barrier for Rust adoption is it's too hard for humans to learn. I believe that's why Francisco has his new book, right? That's to teach humans how to write Rust. A lot of people find it's difficult. Yes, Rust, the handbook, right? That's
Thank you.
So, however, with the emergence of AI, now I can white code Rust. I do that all day long. Have use cloud code to generate something in Rust, which I don't even read the source code. And the beauty is, the coding agent can compile the program, and if it gets something wrong, it's in all likelihood it wouldn't even compile. So you have a very tight, or you have a close feedback loop that's I wouldn't say guarantees the correctness of the Rust program, but gets you like 60% there, right? It still, of course, make logical mistakes and things like that. So if you think that takes the biggest barrier out of the equation. It's just I want to write a safe application for my embedded device instead of writing in C++. I would just have cloud code write in Rust for me, and and I'm gonna I'm gonna have the compiler check it, and I'm gonna just use it, right? So I think those things coming together, I think those are I would say, the perfect storms for Rust adoption on the embedded side, right? That's you would have software that's traditionally written in C++. Like Marco said, there's when you deal with ESP32, so perhaps we take a little detour what ESP32. On the surface, it's very much like Raspberry Pi. So it's a CPU, but it's much less, but it's much cheaper and much less power consuming than the Raspberry Pi.
Especially in terms of cost, I mean, respect to Raspberry Pi.
Yes. And also, because of the chip itself contains Wi-Fi, so you don't need an additional Wi-Fi module to connect to it, so that makes it, because, like I said, the device with Wi-Fi is becoming a standard. So it has Wi-Fi and Bluetooth, so it makes it a lot easier to use in a lot of scenarios, right? So the ESP32 used to have C++ based SDKs. Of course, they all do. If you have a chip, then the first thing you do is to get a C language based SDK, so then people can write software for you, right? But so people in the community have spent a lot of time building Rust native wrappers. Not just the Rust to C bridge, but Rust constructs that are native to the Rust way of doing things, right? Which I'm sure Francisco can explain better. But that's So if you just Rust to C, you just export all the C function to Rust. Then, although you are writing Rust, but you pretty much feel like you're writing in C. But they have an SDK that feels like Rust, right? So that allows us to build. What we want is to have an open source platform that enables all those that allows anyone to build those AI companion, teddy bear with a chip inside, whatever, right? So we want a open source platform that has both the front end and the back end and connect to AI services, but we want to write it from the back end to the front end using Rust. So I guess that's a unique feature of that. It's things like that has existed in the closed source world for a long time, but we're trying to do it in open source, and we chose to use Rust to do it, right? So I'm sure Marco would have opinions on some of those very pro Rust ideas and messages I have just said. So
it's fine. I'm trying to find the right repository because I want everyone in here in the chat to support this open source project. And yes, so it's I don't know. I have not much to add on this. The only thing is that I come more from the web development part. So for me, Rust has been more like interesting because I can create a server with this. Spoiler, we'll also make a demo later alone. But I have a Raspberry Pi, I have an Arduino on my home, and I think that for Rust and embedded systems, I've never made a video because I don't see the real point on doing this. I don't have to convince you because it's basically it's already the best choice. So I might still do some, but there is less friction there. I think everybody's sort of agreeing that Rust is cool on embedded systems. On web development, Francesco has still some work to do. So this is where I'm trying to convince people more. But I think one friend of mine, I don't know if it's here at Harvard, that told me that he likes JavaScript because you can run JavaScript even on a fridge. I would say I would disagree. I think that probably you will run Rust on a fridge, but that was something that I said some days ago. And yes, so I will try to find the GitHub repo. And Marco, would you like to add something on it? And then, of course, maybe we'll show it.
Yeah. No, so I'm totally agree. I mean, the Rust choice is the best for this project probably because otherwise you can run all this kind of stuff on that small hardware. So, I mean, it will be the best choice for sure. No, what I'm interested is really at the beginning why you choose ESP32. I mean, I'm agree it is the best compromise probably, but why you decide to go with it?
Yeah, so of course we have done me personally, I've done Raspberry Pi as well, and we are also, in fact, we are talking to Raspberry Pi Foundation to see if we can port this to smaller Raspberry Pi devices as well. But it's just I think from the hardware side, what we are dealing with is actually a very simple set of hardware, right? Like I said, microphone, Wi-Fi, and the speaker. That's it, right? So we want a chip that is appropriate for that task, and also we want. However, if you look at the future tasks that you can possibly move on the chip, those are very simple voice-based models. For instance, the wake-up word, right? So instead of pushing a button for you to listen to your speak, you can say, "Hi, Michael," and then it would, it would respond and it say it's like "Hi, Siri," or "Hello, Google," that sort of thing. So the wake-up word is actually well supported on ESP32. It's because ESP32 has been used in a lot of those AI, voice applications in the past. Not AI, but you can use certain word to wake it up, right? And the other thing is what we call the VAD, because one of the things the device has to do is to detect when a human speaks versus the keyboard noise or the dog barking and things like that. Because if you send those noise to the server, you would find the server would try very hard to pretend it's human speaking, and it would give you completely nonsensical answers. It would hallucinate a lot if you just send the dog box to them. It would think that it's someone speaking in some language that it imagines, right? So it's best for the device to filter out those voices. And how do you detect human speech? There's also a very small neural network models that you can run on ESP32 that allows you to do that, right? So ESP32 sort of have an ecosystem of voice-based stuff, and interestingly, it also has an ecosystem of camera-based application, because people use it for, say, door cams and things like that. So yeah, that's so I guess the reason to choose it is mostly because of the ecosystem, and also the device itself is readily available.
Yeah, no, I'm totally agree. I really love the choice, because, as you said, for example, for the camera, I'm trying to play with the Echokit and extend it, and I'm trying to add a camera module on it. And the fun part is that also having a camera module for an SP32 is very cheaper. I mean, it costs pretty nothing, and you can extend it in a very different way and customize and build what you want. So I think that the ecosystem is the real value on the ESP32. I mean, also Raspberry and Arduino, for example, a great environment, a great landscape of modules and stuff. But ESP32 is probably at the moment the best compromise on the embedded system. So, I mean, it was a really nice choice.
Yeah, so Arduino is another one, right? So there are lots of those things. But we are software developers. We're not really. We started in ESP32, but we're not against porting it. Especially it's open source, right? That's if anyone in the audience wants to port it to any other platform, I don't think it's that hard. It's yeah.
Yes, thank you. And we still have the poll, which is the favorite programming language. I see Python is winning at the moment, which is mind blowing for being in a channel where basically I talk about Rust every day. So kudos to the Python developers. They are probably calling some friends. I'm joking, but I'll be happy. I'll be happy. I don't know, many people know that I actually coded professionally in Python for 3 years, but I think that people don't know this. They think that I've been coding in Rust since I was born. But yes, so to be honest, I'm interested into something. Maybe we can elaborate more later. More about I don't know if there is a module to make it sort of move, giving something that can make it move, and that's more close to the Arduino world. Is there a module that makes, I don't know, I want to put it there close to the PC and press a button. Is this possible or not? How hard would that be?
Please say it again. You're trying to make something move.
Can I make this? And I don't want to show it. Can I make it like move in some ways? No, just something that moves on a specific command.
Oh yeah, so that is big, because ESP32 has all it does is give signals in those pings, right? It's called GPIO. So so those GPIO, you could have them drive say a screen and output those pixels, and which is what we do. However, I've seen plenty of examples where it can control a motor, right? So
Motor, yeah.
in the world of large language model, you can do it with two ways. One is to use those wake words, like I just said, say instead of say hi Michael to wake it up, you can configure up to 20 words it can recognize. So you can say move forward, move backward, move sideways, dance, turn on your camera, turn on the lights, right? That you can have at least 20 of those. You can also have the large language model to generate tool calls, right? So you can say something, could you please turn on the camera on the living room, and things like that. And the large language model would generate a would listen to this command and would generate a tool call, right? And the tool call would be interpreted on the server, which I can also discuss, because the for the Echokit, the server runs on your own device, in your home, on your laptop. So you can use the server to control your home automation, and you can also use the server to send the command back to the device, so that when the device have a lag and it can move, and things like that, you can have it. Yeah, so I'm saying robotic little robots that based on that, where it can move its heads, move the head around and take a picture, and things like that. I'm also saying people put that on a drone, and you can tell the drone to say, take off and get around that wall and see behind what's that wall. It would understand that you need to take off, go to the wall, turn around, take a picture, and come back. So.
That's super interesting. I've already 2-3 use cases. For example, something that it would be super cool for me is that something that can control during my live event. I don't know, change the color of the lights in background, for example. That would be super cool. My ultimate goal will be to let the people in the chat to control it. So that will be the next level. Based on what you do, you can do this. So that would be interesting. But I would like to see if I can connect it to something physical. I don't know, like pressing a button, moving, I don't know, moving over there, or doing something fancy. So, okay, perfect. If you don't have any other question, Marco, we can maybe showcase some stuff, because we've been talking and introducing, I think, enough. I don't know how many people you have been curious, that you have been looking for it, but now probably we will showcase something. So Marco, anything else?
I think we can start with the.
We can proceed. We can proceed. So we can go with the real show now. So now we are here to do some cool stuff. So Michael, please, over to you, and I would like you to showcase it, show us maybe what it can do, and maybe at some point do some demo. Before I let you speak, I think I saw a great video of you, which was like Rust is the language of AGI. I don't know how long it was that ago, but that was also super interesting. I added this on my to-do list. I will watch it. I don't know if I'll watch it today during the live event or later, but that's also very interesting. So I would like everyone in the chat to just cheer for Michael, because now we are about to see some cool stuff. Michael, over to you.
All right. Thank you, Francisco. Yeah. So here's the Echokit device that I have. So you can see it. That's it's actually has a pretty good design. So you can see the inside of it. You can actually see the ESP32 chip in that. So it was cool. And so what I'm going to do is I'm going to connect it to the. So yeah. So like I mentioned, the device has a server, right? I'm running the server on my local computer, meaning the same computer I'm taking this, I'm joining this podcast from, right? That's so this device, when I connect power to it, let me see, did it come up? Okay, so it's gonna say it's looking connect to Wi-Fi, okay, and it connect to server. What it does connect to server is that it connects to the to the server that I'm running on the computer. So it finds the server on the Wi-Fi network, on the local Wi-Fi network, and it connects to my computer, where my computer goes out to the internet. So I also want to mention that currently at this moment I'm in Singapore, so one of the most remote place in the world, right? So it's far away from any internet center. So every common used software or internet services is slow here because the server is mostly in Europe or in America, right? So that's so what I want to show you is that by running this the backend of this device on my local server, I can get it to respond much faster than say otherwise that I would say run it in America, right? So what I'm gonna do is you can see it's idle, right? So what I'm gonna do is that I'm gonna make it listen.
Yep.
Okay, tell me who you are. What did it say? Okay, sorry.
It's a little bit shy, maybe.
No, I was pressing the wrong button. Hi there. Tell me who you are.
I'm Mr. Docker, your go-to specialist on all things Docker. I'm well-versed in Docker's core platform: Engine, Desktop, Compose, Hub, Scout, Build Cloud, and the new AI-centric tools like Docker Model Runner and Docker Sandboxes. I can help you from installing Docker on any OS, building and running containers, navigating subscription tiers, to leveraging the latest AI features for local model inference and secure agent execution. Let me know what you'd like to dive into.
Well, tell me more about Docker Sandboxes.
Docker Sandboxes, a quick overview, a feature, what it is, why you'd use it.
I love it. I think it's showing something on the screen.
Yes. So, well, tell me about Docker Compose then.
It looks like your message got cut off. Could you let me know what you'd like to learn about? Whether it's another Docker feature, a specific tool, or anything else, I'm happy to help.
I want to know about Docker Compose. Oh, come on. Sorry. So it's always
No, this is 100% live, but this is already, it's giving me goosebumps because you're interacting with this, and so yeah, try it out. It's very interesting, super interesting.
So what about the Docker Model Runner? Huh? Come on. Let me reboot this thing. All right. Sorry. It's
no, I think this is the hardest possible demo in the world.
Yeah.
But it worked. No, it worked quite well. I think that it needs to sync, but it's super interesting the fact that you can. I think go back here. That we can interact in this way. For example, I was something that I was thinking. For example, I take long walks. So having this that I can interact, for example, in a way, or even like in a different way, because, and also, for example, for me, specifically for me, when I go for a walk, I don't want to type. So sometimes, for example, I do videos just to reply to people because I want to take a break because I type so much during the whole day. So this might, give me a break or give you, brainstorm ideas for videos if you want, to create something. I really like this approach. Yeah.
I have to say that I managed also to speak it, to let him speak in Italian. It's really funny because I can really interact with it in my native language. I have a lot of fun, and maybe in another video he can.
We need to add the motors so it can speak Italian properly with Italian gestures. That might be a nice idea, Marco, for a collaboration. If you want, I'm down for that.
Let's do it.
Yeah. So one of the things that you may notice is that it talks very specific things about Docker products, and I even attempt to ask, say, Docker Sandbox, which was released just in November, right? So it can, although one of the problems that shows the rough edges is that it tries to answer with a table, and the speech software have real problem with the markdown table because it has all those dashes in it, right? So that's why it has difficulty pronouncing some of it, So it's a but you may ask, so if I ask ChatGPT or other AI products, what is Docker? It's kind of give a fairly generic answer. But why could this one get a very specific answer about Docker? It's because I'm running my own server, so that I can configure it to use the knowledge base that I specify. So in this particular case, just before we get online, I hooked up a Docker QA, right? So that's the Docker website and things like that, and to it, so that it knows that I'm going to ask it Docker questions, so it can, so to echo what Francisco has just said, it's if there's areas that you want to dive deep into, you have a long set of documents, you have a large set of documents, and you can configure it to talk to you for for a long time. That's perfect for a run, something. Today we see people who's driving those autonomous cars are learn about the subject on your way to work, right? You sit in the car, let the car drive yourself while you ask it questions about, say, nuclear fusion, and and by the time you get work, you already know something about it, right? So that'd be perfect for exercising. That's in that regard, I do think it's a lot better than the generic AI product that you have, on your phone, because you can have, very specific topics. You can give it a different set of ground truths or different set of focus that you need to answer to. Yeah. So, yeah. But of course, I'm gonna say great things about my own product, right? So
Yeah. No, I want to say a thing, because I think that you have mentioned the possibility, and also the stack, the software stack you had to run on your PC is based on Docker. All is containerized, and this is a really interesting choice, because you can really, in a really simple way, spin other containers with, for example, MCP tools or AI agentic stuff, and you really quickly connect, your server, your Echokit server, with a lot of tools, and you can manage to do a lot of things. Like Francesco, you said, I want to control my lights, for example, the color. It will be really, really easy, because you can have your container with your MCP that handle the, your hub for the home stuff, home assistant, and the integration, it is quite straightforward. So it is also a question. So Michael, do you plan to integrate some environment also for MCPs, like an Echokit hub for a set of MCPs already compatible with the server, or do you leave it for the users?
So in Echokit server, if you actually, let me show you this first. So you guys can see that, right? That's the
yes,
screen.
we can see it. We
yeah.
can see it. Maybe like
you can see the whole thing.
like
this is a command I'm running. So you can see the timestamp was just now, right? So when I talk to this device, it goes to this server and it tries to figure out, what to, that's where to send it to, right? So this whole thing runs inside Docker on my local machine, and there's something called configure.toml, which is controls the behavior of this server, right? Which TTS to use, which large language model to use, and which things to use. And in this configure.toml, we have MCP configuration. So there's in this world, I think there's two sets of MCPs. Because one particular kind of MCP that is so widely used that people are typically taking it outside of the MCP now, which is web search. So for most large language providers like OpenAI, you can pass a special parameter to say, answer this question based on web search, right? So we support that. That's if you use OpenAI, you use Grok. If you use, well, there's two Groks, right? GROQ and GROK. That's or if you use, say, Anthropic, whatever, you can tell it to search the internet by passing a parameter in configure.toml. in the configure.toml that you pass into the server, right? So that'd be one very common use of MCP. But you can have your own MCP servers, and that goes back to what Francisco has said. So one class of MCP servers are home automation control MCP servers, meaning you start a server on your local computer, it connects to your own Wi-Fi, and then connect to your Wi-Fi connected devices in your home, your router, your curtain, your your lighting systems, and things like that. You could have it control that MCP as well, so generate command for that MCP to respond to, right? So yeah, there's we do in the system we do support MCP, but as you also know, there's a lot of, I wouldn't say controversy, but there's a lot of people are using MCP for about a year now, and now they have many different ideas about how to optimize this setup, because MCP essentially is to generate programs through JSON and then try to execute that JSON. That's cause that is not a very native or very efficient way of using software. So people are thinking about directly generating code, and that can be executed instead of generating JSON. That gives things like the cloud skills, right? Which is a very popular topic today. And also what they call the code mode, right? So those things, we'd really love to build support for those into our system, and we'd love to see contributions from the community to do that. Because I think that would really bring us to the next step. Because that allows us to do, say, MCP, you call one function at a time, but with skills or with code, with scripts, you can run a whole process. That's a multiple step process, call multiple APIs in one single in one single interaction, right? So yeah, I think that's a great question. That's because we do support MCP. Because MCP has been around for a long time, but not a long time, long time in terms of large language model time. It's a year, right?
In this AI era, if it's 2 weeks old, it's old. So
yeah,
I can feel it. It has been a hard times in the past 2 years. And yes, so yeah, I would like to ask you, like, Michael, what are you showing here on the screen? If you want to show something specific, anything you want, and then I would like also to know, also from Marco, I want to keep it also because I want to know also his experience, because I think you have been using it for sure more longer than me. So yes, Michael, would you like to? Do you think we can do something? It's just a demo, just to demonstrate something, show any code you want.
So normally I would show you the configure.toml here. However, it has all my API keys in there, so I can't show you that. But okay, what I'm gonna do is I'm gonna show you another screen. So
okay,
hold on one second. I'm gonna show you another.
Already two screens shared. So I think it's this.
Yeah. So
let's see.
Let me show
if
you.
You want, we can close your eyes if you want to share the screen.
Well,
can I show it? Yes. This is a rep.
That's how people get wrapped, stacked up with hundreds of thousands of dollars in OpenAI bills, right?
Yes. Because, can you, please make it a bit bigger, and then we can show it. Yes. Julia, my girlfriend, is there to steal your API key, so be careful. No?
So I want to show you two repositories. One is this Echokit box repository, which is how we build the firmware. And you can see, there's 4 instructions. You can read it, but I wouldn't read it here. But you can see there's a cargo.toml, which you can see a little of its dependencies. It has the most important thing is probably ESP IDF SVC, which is the Rust wrapper, what we just talked about, the Rust native wrapper for ESP32, right? So it has all those ESP32 community provided crates, and it has graphics, text, and things like that. One of the more interesting things is that networking is not standard HTTP, because standard HTTP doesn't give you the high speed interaction. It takes time to establish every HTTP connection, so it uses web sockets. So it needs things like that as well, So it has a bunch of stuff. So this is the firmware that's completely written in Rust. And what I would also show you, perhaps more importantly, is the server software, which is also written in Rust. That's what I talked about your team only needs a single set of skills, that is Rust, that does both on the embedded side and also on the server side. So this server side Rust looks a lot cleaner than the embedded side. It's because it's just a WebSocket server, right? So oh, sorry, this is not tomo.configure. Let me show you the tomo configure first.
That was the config cargo.
Yeah, So yeah, so here you can see it's fairly standard. It's I would say a completely standard. That's so if you say R MCP, that's why I say the server has MCP built in, because it calls the LLM. If the LLM returns a tool call, it knows which MCP server to call, right? So this is a Rust crate for calling MCPs. So it has all this. So let me go back to show you the one that I just showed you, the configure.tomo. Configure.tomo is used by this, what we call Echokit server. So the Echokit device contacts the Echokit server, which also runs on another computer on your local network, typically your laptop, right? In my case, my laptop. And what it does is that it has several sections. Let me start from the ASR. So the ASR section does, voice to text, meaning the voice stream that being captured on the device is sent to the server. The server uses this service. In our case, we use another local run service in Whisper, but you could just use the Whisper service from, say, Grok or from OpenAI. They all have, this V1 audio transcriptions endpoints where you can, you can turn voice into text, right? So once you do the ASR, you get the text from the person who just said. You use the LLM. You basically, here is the OpenAI compatible URL. If you have used the OpenAI API, you will know it's typically api.openai.com/v1/chat completions. It's the chat completions API, what they call. You put your own API key here, and you would have the chat. You would have the large language model to generate the response for you. And here is the system prompt, which is what I talked about. Is that when you send message to the large language model, you give it a context. How do you ground the truth? What is supposed to answer, what is not supposed to answer, how it should behave. So you put all those here. And in my last example, I put the Docker Q&A there, right? So you have all this to generate a text answer, so large language model. And then you use the TTS to, the TTS service is another one that does text to speech. So basically, it's another OpenAI compatible URL. It's called v1/audio/speech, where it's you take the output from the LLM and send it to this service and then come back. So it's this is what we call processing pipeline. It's ASR, then large language models, and TTS, right? So a lot of the engineering effort is to make it faster, because if you look at all those, if you wait for one to complete and the other to start, you are looking for 10 plus seconds before the thing responds, right? Because it takes a long time for the large language model to generate a response. If you have used those chatbots, if you wait for the whole response to come back and then go to TTS, it's going to take a long time. So our goal is to make it answer within 1 or 2 seconds, even anywhere in the world, right? So it's configured as a pipeline, but there's lots of engineering work that goes into the process, so that we try to parallelize or try to stream everything. Meaning, say the ASR start to return the result, and as it returns the text, we prepare the LLM's, the KV cache to populate the context for the LLM first, so that as soon as the user question is finished, the LLM can immediately start generating answers. And once the LLM start generating answers, we also stream it to the TTS, so that the TTS can pronounce as the LLM generate answers instead of waiting for it to finish, right? So yeah, there's just a lot of optimizations that we do. So I want to show you a example. So here are a lot of configuration examples using different large language models and different things. So for instance, you can say you want to see an example of MCP. Here's an example. So here's a better one. So the ASR, we use Grok, OpenAI compatible. So V1 audio transcriptions, you just put in your own API key here. Large language model, we also use Grok because it's fast, and MCP server, right? So here we use a MCP server that is running locally. So to answer your question, can I use Docker MCP tools? Yes. If you use Docker to run MCP, they also come up as a local host, by providing HTTP streamable MCP interface. It's a mouthful. Okay, so you can run this MCP server as in another local Docker container, and then you can have the LLM and MCP interact and generate the answer, right? And this LLM can also be a Docker model runner, right? Instead of having the api.grok.com, you can have localhost. I forgot which port Docker model runner runs, but that port and Docker model runner all provide this OpenAI compatible API, which is this V1 chat completions, right? So you can do. So I thought that was interesting because this Echokit server runs inside Docker, and this ASR can run in Docker. This large language model can run in Docker model runner, and this MCP server can run in Docker MCP tools. You can tie all those together in Docker Compose, so you can ship an entire product for this backend for this Echokit as a Docker Compose file, and have your user deploy it on their own home network to drive their own Echokit. Yeah. So.
Yes, I want to make a quick comment on this because this is basically, it's like the dream because it's mixing two of my favorite technologies, my two favorite technologies, also with embedded systems. And I saw that the Axum dependency somewhere in the cargo.toml. So you are using Axum somewhere. I saw it.
Yes.
Because I started a series about Axum like last week, so I'm actually trying to convince people to use Axum. After this conversation, I will have a talk about Rust and web development when I'll talk about Axum. So at least I feel that I'm not crazy anymore because I've been saying this since 2024. Now I still see it popping more and more, and Axum is a web framework for in Rust. So. Cool.
Yes.
I also see version 0.8, so it's also up to date. So kudos, because it's not something. Let's say it's good that you're using a newer version. I'll say very cool. Cool project. Sorry, go.
Oh yeah. So I just want to comment. The reason we use X is because it's not only support HTTP server, it's also support WebSocket server. So that's why we say features WS. That's WebSocket. So we are creating a server. So the server on the Echokit server is run by External, right? That's it has a WebSocket interface. But of course, you can do HTTP with External as well. That's no,
yes.
That's not a problem.
And I think the main reason is that the group, the people who created Tokyo, which is the synchronous runtime for Rust, a sort of node. It's not like node, but just to let you understand, created the Axum web framework. So probably they will be always the first one. So we'll have the support for all these extra thing, and this is also why I switched, and now I'm more focused on Axum. So I didn't even know this before this live event, so now I know that what will come later, it will be perfect because I will talk about Rust and web development, and then I will make an Axum demo. So this is the perfect hook for later. Yes, Marco, any comment on this?
Yep. Yeah, I have a question more than a comment. As you said, it's really beautiful that you can ship all the stack in Docker Compose. So it's really easy to spin up any kind of application. So my question is, have you already sized a possible hardware that you need to spin up a quite large application based on this stack? Like I have my Echokit and I have my computer or something like that. How big it had to be this kind of computer or this mini server or this mini PC? So it could be really interesting having some numbers,
Yeah, so the biggest barrier really is the large language model, because that's by far the most
exactly.
computational. Yeah. So so one way you can do it is you can have everything on your own computer, but except the large language model. So you can do that, right? That's so you dedicate that to somewhere else. If you want to have the large language model on your computer, I would recommend that you have a device that has an actual GPU. Not the Mac more or less works, but but it's still fairly slow when it comes to voice interactions. That's and also you can choose one of the smaller models. So for instance, in the open source world, the GPT OSS are actually really good models because they are MOE, meaning at any given time they load part of the model into the memory, which make it a lot more efficient. Definitely useful by, say, if you have a 4090, NVIDIA 4090. If you're a gamer, you probably already have those GPUs, right? So
I have it. I have it.
So-
I have it.
Yeah, already.
It's over
you're
there.
ready. So. Okay.
but
No,
it works
it's
perfectly fine
interesting.
on the Mac. Yeah. So if the
Yeah,
Mac
okay.
has maybe not the bare minimum Mac, but say the newer Mac with 16 gigabyte memory or 32 gigabytes memory should be sufficient.
Yeah, no, I think it's interesting because if someone want to try it, so he had already the numbers in mind. So if you already have a quite normal MacBook, you can already try to run a complete stack of Echokit server, and I think it's quite funny. And you can build stuff on it. And about it, I want to ask you a question about the possibility to ship something with the Echokit. So, I mean, if someone is really interested in developing something, what are the first steps that he had to do to start building something on Echokit, in your opinion? Some suggestions, some.
Well, yeah. So I think if you are interested mostly on the server side, meaning you are interested on the AI side of things, then look into the Echokit server. You actually don't really need a device. You can, of course, you can buy a device. I would like you to buy a device, but you don't really need that. Because we have a it's on our documentation page. We have a web page which you can run locally that use JavaScript to connect to that server, because the server is just a WebSocket, right? So you don't have to have that device. You can just use your computer, your browser, use a JavaScript that running on your computer to connect to that device, to connect to the server, right? So if you primarily want to do customize the AI part of things, perhaps adding more support for new AI models or new AI services, adding support for cloud skills, like we mentioned, right? Instead of in addition to the MCP support, improve the MCP support or whatever, right? So I would really appreciate contributions on the on the Echokit server side. But if you are well versed in development on the client side, and say as I mentioned, we are also looking to port it to Raspberry Pi, for instance. We love the ESP32 platform, but we also understand a lot of people already have a Raspberry Pi, and if they can try it, that'd be great. That's so we are also one of the challenges that we have is that we want to find a universal build system in Rust that can just change your configuration. It's going to build different firmwares, right? For ESP32, for Raspberry Pi, for Arduino, whatever, right? So that's one of the challenges that we have. So if you are I don't think it's really for beginners, who's just learning embedded programming, but that's something we are looking for. Yeah.
Yes, and I've also, as I said, I have a Raspberry Pi. I have a talk in a couple of months in Rome, which will be about Docker and MCP and Rust. So I'm thinking about bringing something with Echokit, but I'm still brainstorming in my mind this. But I'm sure that will be cool. By the way, I wanted to show also mine, which is here, which is a different one. This is a DIY, the do-it-yourself. Of course, I will record some stuff with it. This makes me really super excited. I want to dive deep more into it. Just one quick question is that I saw in the examples there are some config.toml files. So basically you can switch them based on your project, if I got it right
Yes.
or not. I got it right.
Yes.
So based on your
So-
project, you can use, let's say, prepared, pre-cooked config.tom, right?
That's correct. So
Okay, got
you can see we have many examples, right? We have Grok example and Grok example, right? So if you see
Grok
this
chat.
chat, so this example use everything from Grok, the XAI stuff, right? So and this example use everything from Grok, the NVIDIA. Who bought them? Who bought Grok? NVIDIA? Yes. So NVIDIA recently bought them, right?
Yeah, NVIDIA.
That's
Yeah.
So
NVIDIA bought Grok?
Yeah. Grok with the Q. Yeah.
with the
Grok Q, okay, Grok Q.
Yeah,
Grok Q, okay. Sorry.
yeah.
Just because our life is not confused enough.
Yeah, exactly.
Got it.
Exactly.
Perfect. Love it.
So we have Gaia, which is a decentralized Web3 inference network. We have Alibaba, which is for our Chinese users because they can't use any of the Western models. So they have a whole set of things, which is, by the way, also OpenAI compatible. A lot of, in this case, chat completion is OpenAI compatible, but their TTS and their ASR are not. So there's a lot of different configuration files that you can use, and that's why also when you look at the Docker command I used to start the project. Let me quickly switch back to the Docker command. Right here. Okay. If you see the Docker command at the top, where I used to start the where I used to start the server, right?
Still see the 1 second. Are you sharing the console?
Yeah, I'm sharing the console. At the top, you see Docker run, right?
Yeah.
And the port 8080 to 8080 maps the container port to the host port. And then -v, the configure.toml in your current directory into the app configure.toml inside the Docker container. This configure.toml, you can change it, right? You can change it to application1.toml, application2.toml, the app1. So when you start the server, you can just map a different toml into the Docker container, and it will start.
Interesting. Super. I got it. Okay. Or it can be the same file with different content, but I think you can just, no, because if you change the name, but if you keep the app config.toml as the same, it will be copied as config.toml.
Yeah.
That's correct. Yeah.
Cool. Got it. That's a nice trick. You can have different configurations, and then you just locally you have different naming for config.toml for your mental sanity. But then when you send this to your server, it will always be default config.toml. I don't know if there is a way to provide a custom config.toml file. Maybe there is an option. I don't know. But super cool and super interesting. Thank you. And we shared the repository already a couple of times, but I will share this another time so you can check it out. No, I saw share this one. Very cool. Okay, perfect. I wanted to ask you, Michael, what do you think it will be something that you or this project will change or go into in which direction it will go in 2026? Also for me, in ideas for maybe some future collaboration and stuff. This is very interesting for me. And if you have any questions, just drop them in the chat.
Yeah. So so there are two aspects of the project, right? One is on the device, where we want to push more. We want to provide an example of using Rust in the embedded space, because I think it is a very good use case for Rust, but there's not a ton of good open source projects that people can learn from. So we were hoping that's and we will also try to teach AI how to do this, so that maybe AI can write some of our code. So that's on one side of the things. It's on the embedded device side, and on the server side, I think the software is much easier to write, because the paradigm is a lot easier to understand for people just making web services calls, web requests, and things like that. what we want is that we want to support more. Today they call it AI infrastructure, but context engineering. So, for instance, search proprietary knowledge base. Manage the memory, the context. So that with every turn of conversation, I rewrite my memory so that only the important points remain, and things like that. There's lots of innovations in the space that we really want to integrate with the Echokit server, so that the goal is really to make our response more intelligent. Yeah. So that's. But yeah, I would think that's also a pretty good Rust project. That's it's not just in Rust. The most common thing for people to do is system software, right? A lot of people on the application side, a lot of people use Rust to write CLIs, which is popular now. And some people are also using Rust to write web servers, like you said. That's HTTP servers. But I think we are providing perhaps a different set of a different kind of infrastructure software, which is a gateway or a proxy, something like that. It's on one end is WebSocket. The other one on the other is connect to all kinds of different services on the other end, and it's aggregate everything together. Yeah. So.
Yes, absolutely. And also, I think that we should also consider the fact that, for example, and I've done this during a live event, I think a couple of weeks ago or last week, and I tried to run an Axum server on my machine, and without Docker, it takes 4 megabytes of RAM. It's not a typo. Or less than 6 megabytes of RAM in production on DigitalOcean. So, of course, on your PC, maybe you don't care, but when it's about like these very small devices, in that case, it might really make the difference. So
Yes.
it feels, like going back to the 20s or the 90s when, we had to count every single bit. Now this problem has been a bit switched, so maybe it's not more on our personal PCs, but when it's about, buy a server or even run a service on a device, I will use this in my talks and in my examples when I need to say that, for example, in this case, it would really matter. So I would explore this amazing project again, for sure. Okay, perfect. So we are almost at the end of this first part of this long Saturday live event, because after this I will have talk that I prepared and I gave at Rust Africa Hackathon on the 3rd of January, and it's Rust and Web Development in 2026. And I will mention many things that we have talked about here already, so I'm super excited. And after that, I will also make a demo, the second demo on Axum. We'll starting from the basics, but I'm doing a Axum series. Before that, I want all of us to have some final thoughts, share something. Maybe I want to ask Marco a bit about his experience before we wrap up.
Yeah.
So now, first let's go with Marco. I want to know your personal experience. Michael is watching, but you can share your experience. We want the honest feedback, Marco.
So no, really, Echokit is really I love it because since I had it, it's so easy to spin up. I mean, it's just plug and play and it runs. The software is really well done. It works out of the box. You just provide the config file and it works. The philosophy of its modularity, also in terms of hardware and software. As said, I like to play with hardware, so I'm trying to extend the hardware with other components like a camera, for example. Also, I appreciate the continuous development. I mean, quite every week, new updates comes up in terms of we have a new support for a new chat complete, a new LLM, it's always in progress. So I think people should keep an eye on that. And last but not least, the full integration with Docker. I really appreciate it because, make things really easier to do. It's operative system independent because you can run all the stuff on Docker. So you don't need to handle cargo stuff and Rust stuff. And it's quite funny for me not handling Rust stuff. So yeah, no, my experience was very fine. The only thing I try to play with, and at the moment I didn't succeed, is the voice cloning. It's not so so easy, I think. But yeah, it's a work in progress stuff.
Because it's hard to clone our Italian voice, Marco. probably.
Yeah, it's all my bad. Yeah, sure, it's on me. It's not the problem of Echokit. But yeah, no, it's a very promising, I think, project, and everybody in this field that want to have a more feeling of things, like touch something, not just typing, should keep an eye and maybe try it. And regarding this, how it's going, the poll about Rust and Python? Quite
Okay, so okay, Rust is winning, but not by much, because Python is 30% and Rust 45%.
So,
but
you bring your friend. So
for being a channel so Rust focused, I'm honestly impressed. So kudos to the Python developers, of course. And yes, I'm curious about making it move in some ways. So we might even collaborate, Marco, because I want to work more adding a motor, wheels, or a button that can be pressed. So I'm really curious about it. This is a project that I wanted to do like 10 years ago, 15 years ago during university. I wanted to have an Arduino with this project, just to press a button remotely, but it was, I think, 2005 2006, so probably not that easy. It was 20 years ago. I had this idea to have control, to press a button remotely. Maybe it has been 20 years, but also it was not that easy back then, also because I was doing other things. I see that now I might get this project back now, because it seems maybe it's a bit easier compared to 20 years ago. And so yes, I want to complete this thing that has been in my head for more than 20 years. So I'm looking for, and I will expand this project, because, for example, you solved, for example, a problem for me, because of course I am into Rust a lot, but I do many things in the meanwhile, and I don't have, for example, the time, I don't know, to bootstrap or start with something from scratch. I haven't done this, for example, so far, for example, with the Raspberry Pi. So for me, it really makes the difference that I have this project already with Rust shipped, and then now I am almost there. I have just to add a couple of modules and add some logic. So for me, this project makes 100% sense. I will recommend everyone to have it and check the links below. Not just Docker, so it's I don't know how I didn't know about this. Probably I've been too busy traveling for conferences so far. So, but finally, because we met this like in Turkey when we met, so it was quite shocking for me, because yes. So perfect, Michael. Any final thoughts on this? And if you have any questions, you can drop it now.
Well, I would just make one point about Rust versus Python then, because like you mentioned about the poll, as we all know, the RAM price is skyrocketing. The DRAM price, I think, people are talking about 16 gigabytes of RAM going to be more expensive than 5090 GPU soon. It costs thousands of dollars. I think it has gone up 4 or 5 times this year alone, because all those GPU providers are buying them up to ramp up manufacturing. The reason I'm mentioning this is because more than ever we need memory efficient programming language and programs. So with so the Echokit server, I would say, takes less than 1 gigabyte. Couple megabytes, right? Definitely less than 10 megabyte. We could use Python, of course, but look at the dependency of Python, man. That's gigabytes and gigabytes of dependencies, all right? So,
but no, okay. So I want to defend Python now, because you are bashing it on the channel. Because Python is not meant for that. So it's normal that I don't know. for example, Rust doesn't even come with async runtime by default, for example. So it's a good thing for these devices, because maybe you need it, maybe you don't. And I think this really shows how maybe an efficient programming language can be useful in some unpredictable ways, and we have no idea what this will happen. But this is this is one of the reasons why the C language is still here after 50 years, because if the language is efficient, it's not going anywhere. And I think that especially now that we have AI, for me, it already doesn't make much more sense to make a backend in a different programming language. Maybe I'm a bit different because I'm so much into the Rust ecosystem. But slowly, people will just see, okay, I can just do this with AI. I just have to choose the language. I think that the AI is working for us in this way, because you have to choose. Maybe it's better to at least check the Rust bootcamp by Francesco before just doing Rust stuff, please. But it's interesting. So, and of course we can integrate with other systems. So thank you, Michael. Thank you, Marco. And I don't know. I'm happy because I've done this at the beginning of 2026, so I can bring it. If I do some talks, and I will mention, of course, I will let you know. Michael, Marco, we need to collaborate before 2026 ends. And I will really be happy to collaborate with you. I know that you have been working, we've been playing a lot with embedded systems. You also have a community, I think.
Community about hardware.
Exactly. So I left the links below, both from Echokit, Michael and Marco. So check them all, and yes, perfect. So really happy, Michael and Marco. You really made my Saturday. It's not over yet because I need to do. I have now this routine of like recording my talks on my channel, because I've done so many. But this is something that I was not used to do. Now, since I've done this, before I forget it, I want to record it. So if you didn't have enough Rust for today, you can stay a bit for a while. And we are done. I think I'll take an espresso break, and then I will get in. So, thanks, Marco. Thanks, Michael.
Thank you very much.
See you. Excited for the future of Echokit. I think it's a very promising project. I will do my part, no worries, Michael, to help this project, because this is currently my standard for embedded systems. So, for sure, that's it. Bye, guys.
Thank you very much.
Bye-bye. Bye-bye. So let me do this and this. So, okay, bye. I have two. Okay, perfect. So we are done with the first part of this live event, because we are not done yet. We are not done yet because, first of all, I'll take a break because it has been already more than 1 hour. And then we will have a presentation. And then maybe we'll also have a demo. So we're not done yet today. But let me know what do you think about this project before I take the coffee break. What do you think about this project? Is it crazy? Is it good? 1 second, let me do this. Okay, perfect. What do you think about this project? I really want to play around with this project. I want to show it again like this. You see, it has this. Now I can't connect it, but it really looks super cool. I still have to remove this thing. It's something super cool, I think. This was very interesting. No, I was thinking about you can use it, for example, to prepare your thesis. You create it, you speak it. I don't have the module that let it speak, which I think it's a very interesting one. But basically, when you have a device like this, you can buy some extensions. You can buy some extensions. For example, I want to buy something that make it move, like you click a button, or something that can make it speak. Or you can even, buy a sensor, for example, for humidity. For example, for this house, you can add stuff. So this is a physical device. And this is the difference between this and a PC or a laptop. You can extend it. I can't buy a wheel for the MacBook. This is a small device, and Okay, so now I will take a 2 minutes break and then we'll have a talk. Interesting. Yes, yes, and I think it's interesting if you because at least you take a break in in just typing. Otherwise, you just type all day long. I want so let's have 2 minutes break, okay, and then I'll be back. ESP32. I don't even know these devices very well. I will show it again. Probably you are more experts than me. I don't even know the names of these. So this is an ESP32, right? I'm not much into embedded systems. I'm more into Rust and web development. But since I like Rust, I'm here exploring this thing. So now I'm also exploring in this. And I love that finally I have time to do all this sort of stuff. So I want to put this maybe here. I want to put this one here. And I will be right back in 1 minute. Is my favorite microcontroller. If you have some comments about the past thing, maybe you can even drop some ideas of projects that we might create. We might even do this in a long live event. That will be super cool. That will be really super cool. I want... okay. So I want to share this one. Share screen. Entire screen. Okay. Okay, let me do this. I want to take a 1 minute break. Dumb question. What is an embedded system? This is not that easy. What is the definition? It's probably it's like a device. No. Grok is not embedded. Embedded system is like the physical device. It's like a physical device that can that has like a micro CPU. It's usually way less powerful than. Let's start the definition. What is an embedded system? No, it's not a dumb question. Specialized computer system with a dedicated hardware, usually small. Usually it's to perform a specific function. Classic example of no. A classic example, I don't know, is a webcam. The webcam that you use, to control your house. That's an embedded system that you buy, and it does something. The cool thing of these is that they are customizable. You can actually buy a camera for this. You can buy a humidity sensor for this. I want to buy, for example, a little thing that makes it press buttons. No, because you run some software on it, and the software can, of course, be something related to artificial intelligence. It's probably the most interesting thing to do. It can use different models. Let's try something. Embedded systems for bioinformatics. Crucial. Okay, here we read this. This might be interesting for you, Julia. Embedded systems are crucial for bioinformatics, enabling portable, real-time, and efficient processing for tasks like sequence analysis, genomic pipelines, and wearable health monitoring. Yeah, but this is what they are. Because this is the definition specific for bioinformatics. You see, all these tasks can be done on this device. But even me, a nice idea for it. The cool thing is that these small devices, they are super interesting because they are physical, they are hardware. So if you can, run some health monitoring on these, you can add a sensor that does something, for example. It's super interesting. Yes, of course. Of course, embedded systems are way older than AI. I wanted to do this like 20 years ago, this project of a system that clicks a button remotely. It has nothing to do with AI. AI is a software. Now you can use AI on embedded system, but embedded system has been around for 50 years, 100 years. It has not. It's like saying that like laptops they work with AI. That's the normal evolution of systems and software. I need to take a break. Stay here because then we'll talk about this talk that has been really interesting because this is also up to date for 2026. Rust and web development in 2026. So here we talk more about Rust and web development and not Rust and embedded systems. I will still mention a couple of things. Something which is super interesting, then I'll take a break, is that I saw that Echokit uses Axum. Mind-blowing. I didn't even know this before the live event. Incredible. We will do this, and maybe after this, if I still have some energy, I will do another demo with Axum. We'll do the second part of the Rust and Axum tutorial, and I want to record it live because I'm lazy. Okay, be right back. Okay, I'm back. Let's have a couple of minutes break, and then we will have at least the Rust and web development talk that I delivered at Rust Africa. We don't need AI for embedded systems. It's not that we don't need it, it's that it's something newer. Embedded systems has been around for a while. I'm not sure if I agree that we don't need it. It might be useful. Okay. I want to make a tweet about this. Can you see? I like this format. Can you see? No, I want to take with the no. I want to take the picture with the coffee. Like this. Okay. Let's make a post here. I'm excited. Are you? Okay. Amazing live event so far. Now we are talking about Rust and web development. Which programming language would you suggest for beginner to start with, Python or Rust? All the Rust people will tell you Rust. I'll tell you Python. I'm kind of unique in the Rust world. Don't hate me, Rust lovers, because I think that everything has the right moment to be learned. You will reach Rust at some point. Feel free to ignore. If you ignore my tip, this will make me happy. But I need to be honest with myself. Are you shocked by this answer? Maybe you are. You will learn Rust just to disappoint me. You will not disappoint me. I'll be happy. Live link below. Okay, then here. Are you ready? Are you ready? Rust and web development in 2026. This is a talk I delivered on the 3rd of January 2026. Let's go here. Share. Julia, why are you hiding? What happened? Hanum. Thank you. I don't know how to spell your name. Haunam. Ahunam. Haunam. How? I don't know if I have to spell the H or not. Let's end the poll. Rust won, but Python was close. Okay. Are you ready? Shall we start? I hope I remember this talk. Okay, let's put it here. I still want to check the chat from time to time. Okay. I will click to update. You were joking about us being disappointed. So what am I? Yes. Got it, Julia. Okay, are we ready? Rust and web development in 2026. We are ready. Now let me finish my espresso first. I see many people from Africa excited about Rust. I don't know. Are also people from India excited about Rust? But I see people from Africa really excited. By the way, I am a bad marketer. I should show the book more often. It's fine. Okay. We are ready. Let's start. Should we start? Are you ready? If you're ready, we can start. Let's start. The libro. Yes. I'm sorry. When I get excited, my Italian just pops out. No, it will. So it will have two things now. First, this is a talk. It's a presentation. This is a presentation, storytelling, and then we'll have the second part of the Axiom tutorial. So two things. Yes, it is. It is. Do you want the link? I can share it, but I tend to don't over promote it, because if you this is something that if you want, you can buy. I will share this link. So here you can check. Here you can check the boot camps. Also, we have another book. We have a boot camp on Friday. I forgot to promote it. It's fine. We have more than 300 people here. This is wrong. Okay. Okay, let's start. Okay, we can remove this, and this. Okay, ready? Okay, let's start. I hope you can hear me. I can leave it. Okay, why is it not full screen? Now it is. Okay, let's start. I'll put some water. Many people attended here, so this is an opportunity in case you missed this one. Okay. Hello everyone, today we'll talk about Rust and web development in 2026. For the last 10 years, the question about Rust on the web was always, is it ready yet? Are we there? Maybe it was an experimental choice, but in the next 20 minutes, more or less, I will show you how maybe this answer changed over time. So we stopped asking if it was ready, and we started realizing that maybe it has become the default choice for stability. So I hope you're excited as I am, and let's start. And I want to start with this slide that shocked me. This is part of the Stack Overflow developer survey. More than 25,000 developers replied. And of course, Rust won the favorite programming language, I think for 10 or 11 years in a row. I don't know, I lost count. But I don't know how many of you know about this. They asked, which web frameworks and web technologies have you done extensive development work in over the past year, and which do you want to work in over the year? And maybe you can see here at the top, Node.js, React, jQuery, Next.js, frameworks that you probably know, Express. I made many videos about this. But can you see it? It's not at the bottom, but it's close to the bottom. Axum. It's here. This little thing is, to me, is mind-blowing, because I've been talking about Rust and web development since the beginning of 2024, so 2 years ago. 2 years later, Rust is in the Olympus of the demigods of the web frameworks. I mean, Fastify is 2.9%. Maybe you heard about Fastify, or Next.js, or Astro. It's here. Axum is here. This, when I saw this, I said, okay, Francesco is doing something right. I also want to show you this. This is a quite reliable website that talks about the best fortunes response per second. Okay, and check here at the language on the top. I don't know if you can read. Like Rust, and check number 7, Axum. So Axum is quite performant in web development. It's comparable to C and C++. You see here, like Java is over here with Quarkus. So this is really, really interesting to me. So maybe Rust can be used for web development. Let's go to the next one. Okay, before we talk about the frameworks that maybe you will use every day, I want really to acknowledge the engine that powers them, because unlike Node.js or Go, Rust doesn't ship with a built-in runtime or event loop. And I think that this is a great solution. So you might use it or not. So this leaves the choice to us. And for the last decade, the ecosystem has united behind Tokyo. I'm so happy that we don't have 2 or 3 runtimes. We have just one good runtime. This makes me super happy. Tokyo is also the company that created the project that created Axum. So you can think of Tokyo as the async standard library for the web for Rust. It handles all the scary stuff, so threads, pools, input-output, multiplexing, scheduling tasks across cores. So the framework authors don't have to. Framework authors, they use Tokyo, and Axum is one of them. In 2026, you rarely interact with Tokyo directly, but it is the reason your Rust server can handle thousands of concurrent connections while using just a fraction of the memory of a Java or Node application. This is the rock-solid foundation that we can build on, and this makes me very happy. So in 2024, the question, can Rust handle backend traffic, was already answered. There were back then some Rust frameworks. Big tech companies, they had already proven it in the past. But now, in 2026, choosing Rust for the backend is probably the boring choice. And I mean this as a compliment. I will use now Axum in production for a SaaS. I think I'm ready. 2 years ago, this was not my answer. We need to choose between Axum and Actix. I think these two are the most important choices at the moment. Axum is the default choice for most of the teams, also the favorite choice for the Echokit. So Echokit also used Axum. This makes me really happy. It's built by the same people, as I said, who make Tokyo, and it really feels modern, modular, which is a great word in the Rust ecosystem. And the good news is that if you're coming from Node.js, Express, or Go, it will look very familiar. And also there is another option, which is Actix Web. We can call it the veteran. If you are building high-frequency trading platforms or systems where every microsecond counts, probably Actix is still the raw performance champion. I tried with Grafana K6 some benchmarks between Axum and Actix. I didn't have time to put this in the presentation, but I tried this. Actix is still slightly better than Axum, even if it's not that there is not much difference. But regardless of which you pick, you get the real superpower of Rust. What is the real superpower of Rust for backend services? You don't have a garbage collector. So there is no a random 200, 300 millisecond pause on HTTP request. You have a flat frequency. You have a flat latency. This is great. I want to take 1 minute. I will do something with Axum is practical. Before I leave the backend, I have to give an honorable mention to one of my favorite tools in the Rust ecosystem. This is becoming one of my favorite tools, which is SQLX. Have you ever used that? Let me know in the chat. Yes or no. Just type yes or no. Yes, SQLX and no SQLX. Now, usually we reach for an ORM, which is an object relational mapper, like for example SQL Alchemy for Python, because we are afraid of writing raw SQL, because we don't want to make typos. I make many typos, for example. SQLX changes the deal because it lets you write raw SQL queries, but it checks them at compile time. So when I run cargo build, SQLX actually connects to my development database, inspects the schema, and checks my queries. If I misspell a table name, compile error, and it is great. If I try to select a column that doesn't exist, compile error. If I try to put a string into an integer column, you guessed it. So it really gives me the confidence of an ORM, but it doesn't slow the process. So this comes with the raw power and performance of handwritten SQL. In 2026, this is still the gold standard for data access. And now that we have talked and let's say conquered the backend, I want to cross the frontier into the browser. How do we get Rust running inside Chrome or Safari? Can we actually do that? Yes, we can, but we don't ship the source code, we ship binaries. This is WebAssembly. WebAssembly is not just something just for Rust. WebAssembly can be used with many different languages, C++, Rust, Python, Go. But for this specific use case, it allows our Rust code to run alongside JavaScript with near native speeds. I have to say that WASM by itself is isolated. It can't touch the DOM or listen to click events. It's just basically a calculator in a box, and we need something like enablers to make it useful. We have, for example, WASM bindgen. You can think of this as the diplomat or the bridge, I would say. It handles all the complex conversations between Rust types and JavaScript objects. You rarely touch it directly, but it makes the magic happen, to make it happen. And also we have WebSys or WebSys, and this is the vocabulary. If you want to use document.getElementById or, for example, window.fetch, you can use WebSys. It provides raw Rust bindings for every single browser API. In 2026, you don't need to know the binary details of WASM. That's not needed. This creates abstract it all away so you can just write your beloved Rust code. In the early days, the Rust frameworks like you, I don't know if you ever heard it, they looked at React and said, let's do that, but in Rust. And we adopted basically the virtual DOM. The virtual DOM, probably you already know, this works by taking a snapshot of your UI like this, taking another snapshot after a change, and then what it does, it compares all of them and it will find the differences. But then, of course, this is like rewriting an entire essay just to fix a typo. It works, it's a bit overhead, and in Rust with the compile times, it might be not the ideal solution. There are some modern frameworks like Leptos that realize that we don't actually need a virtual DOM. Why? Because Rust has such strict ownership rules. So let's use ownership. We can use fine-grained reactivity. You can think of it like an Excel spreadsheet. If you update the cell A1, for example, Excel doesn't redraw the entire sheet, of course, but it instantly updates only the cells that depends on A1. And this is how the signals work. When you update, for example, a counter, the framework doesn't re-render the component, but it surgically updates that one text made in the DOM. For example, here in this one. It is in O1 constant performance. And this is the fastest possible way to update a UI, to update a user interface. Now, if you're building a pure web application, like a SaaS dashboard or a social network, I think that laptops might be the default choice in 2026 because it solves two biggest problems of the past: speed and SEO. Laptops is isomorphic. That's a fancy word that means you write your component just once in Rust. When a user first visits your site, the server runs that component and sends pure HTML. This means that Google can read it perfectly and the user sees content instantly. And then the WASM binary loads in the background and hydrates the page and takes over. It becomes a fully interactive single page application. And for those of you coming from the JavaScript world, Leptos feels exactly like Solid.js. You use signals, you use JSX style templates, but you get the type safety of Rust. And it's very fast because, unlike React, it does almost no work at runtime. Now, while Leptos focuses purely on being the fastest web framework, Dioxus takes a different approach because Dioxus aims to be the React native of Rust. This is super interesting. I want to bake a mobile application using Rust in 2026. If you need to build a web dashboard, but you also need a native desktop app or a mobile application, I think Dioxus is a strong contender because it allows you to write your UI logic once and deploy it to almost any screen size or ratio. It uses the virtual DOM, Dioxus, and hooks. So if you are coming, for example, from React, it will feel very familiar. I want to say something. I think Dioxus is a sort of jack of all trades. So if you're building only for the web, you might find it has a bit more overhead than Leptos. But for cross-platform consistency, it is currently, I think, the best option that Rust has. I want to talk about this that might become the holy grail of the full stack type safety. This is the superpower that JavaScript, even with TypeScript, cannot fully give you because we use something called the shared create pattern. We create a folder called common, and inside we define what a user looks like. Check this one. We define our error messages and we define our API responses. The backend imports this create to talk to the database. And the front end imports the exact same crate to render the UI. And here is where the magic happens. Because if I go into that common crate here and rename, for example, user.name to, I don't know, user.full name, my entire stack stops compiling. And how is this? Good or bad? This is amazing. The backend refuses to build because the SQL mapping is wrong. The front end refuses to build because the UI component is trying to read the old field. But the cool thing is that I cannot ship a breaking API change by accident. The compiler literally won't let me. It eliminates an entire class of integration bugs forever, and you can sleep well. Rust developers, they like to sleep. I want to show you exactly how it looks, because I think this is simpler than you might think. Here, we start here in our common library, and we define a simple struct, like here, called to-do item. Okay? This is our contract. This is the, let's say, the source of truth. Then here on the server, here, my API handler explicitly promises to return a list of these to-do items, a vector, okay, of these to-do items. If I try to return anything else, the compiler will stop me. And then here at the bottom right, we can see that on the client side, I don't need to manually type a TypeScript interface that matches the server, or even worse, use JavaScript dynamic things. I just use the same struct. And if I change title to task name in the top box here, both of the bottom boxes, they break instantly. Amazing. I fixed them, and now I know for a fact that my production app will not crash due to a mismatch. Can you see it? Now, I should just say that Rust is amazing, and probably it is. But I really want to be transparent, because even in 2026, Rust on the web is not free, not because it has a premium tier, but we pay a tax for all these safety and performance. First, the compile times. Rust is famous for being slow to compile, and this is the source of all the Rust memes. The compiler is doing a massive amount of work, checking every borrow, optimizing every loop. It hurts that fast editing refresh loop we love in JavaScript. We don't have it here in Rust. And also the binary weight here. In JavaScript, the browser already has the runtime, already has a JavaScript runtime. In Rust, we have to ship all the standard library inside our WASM file. So a hello world, it will always be heavier in Rust compared to JavaScript. And also, third, the monomorphization tags. That's a fancy word for code bloat, because Rust generates unique machine code for every generic function you use. So your binary size can grow unexpectedly fast if you aren't careful. We accept this cost, but of course we don't ignore them. And we didn't just accept these problems, but in Rust they engineered a solution for this. First, for the developers, hot reloading. Rust solved the slow compile times. How? By cheating. Modern frameworks like Leptos, they don't recompile your whole app when you change a button color or a margin. They patch the running binary in memory. So it feels like editing JavaScript, but with the Rust safety. And second, for the users, the island architecture. We stopped trying to ship the entire application as a heavy WASM thing, WASM blob. You can imagine your website like a sea of static HTML, fast, light, and readable, of course. And inside that sea, we can place some small island of interactivity. If you have a blog post with a like button, all the text is HTML, and only the like button is Rust. This keeps your initial load time basically instant, even on mobile. So, what is the final verdict? In 2026, the Rust ecosystem is different from the JavaScript one, because we don't have 5 million packages on NPM. We have a smaller set of rock-solid interoperable tools. We choose quality over quantity. So when should you use Rust? I think we can use it for the sweet spot, complex applications. If you are building a fintech dashboard, a collaborative editor, or anything where a bug costs you money, and if you value maintenance over the setup time, I think that Rust is the winner here. But I have to say that we should not force it. If you are building a simple marketing site or a personal blog, I think that Rust is an overkill. Feel free to disagree, but I think that Rust is an overkill in that case. My personal blog is still in JavaScript, in TypeScript. You don't need a compiled binary to display some static text. You can use a static site generator. This is why they still exist. But for actual application, especially mission critical, I think that the answer is clear here. So the big question is, again, can we use Rust for web development in 2026? Are we there yet? Yes. Or at least, why not? I wish you best of luck in learning Rust. Thank you so much. Okay, perfect. What do you think? Did you like it? Let me check here. Okay. Do you think that you will use Rust in web development in 2026 or not? Hey, Sebastian. I think I want to use it more. The interesting fact is that I've been doing this since 2024, and now I'm happy because I've done that. So let me remove this. We can have a quick chat, and then we will also. I also want to do the Axum tutorial. It will be a very long Saturday, but I hope that you appreciate this thing. Perfect. Rust in web is my first option always. Amazing. I'm pushing in my job to implement it because we are running a lot of .NET legacy slow services. Okay, cool. Spread the word, Sebastian. Spread the word. I mean, now that we have AI, what's the point of not using Rust? Maybe I'm a bit extreme with this statement, but I start to not see the reason why I should not do simple projects. The only thing that might hold me back is if we are missing, I don't know, a specific library, or we need to have, I don't know, a specific implementation. But for normal HTTP services, HTTP servers, why not? My question is why not? SQLX with compile time, yes. How Rust use a warm approach with DB and how? I don't know, Biagio, if you're still here, we have a question which is how Rust use a ORM approach with DB. Rust has different ORMs. One is called Diesel. And I didn't like it much because you need Postgres installed on your machine to run basically the Diesel CLI. I find SQLX way better because it's not an ORM. It's just checking the queries at compile time, which I think it's 10 times better. Perfect. If you're ready, we can already go to the next one. Actix has been one of the first frameworks that I tried. I think it's slightly more efficient than Axum. I did some benchmarks before, of course, saying this on my channel. It's slightly better. But for example, even Echokit uses Axum. But I think that's because of a better integration with WebSockets. Because otherwise, maybe on Echokit, you want the best performances. But I think Axum and Actix are very similar. The thing is that even Axum is a bit slightly less efficient than Actix, like I think 5% less. It might have a better maintenance and a better ecosystem. And I think at this point, this is very important. It's very important. I don't want to waste time in learning a framework that then I will not use. I know that now we have AI, we might switch faster, but I don't have time because I have to learn about AI. I don't have time to waste on a framework that will stop being maintained. Otherwise, I will still be in the JavaScript ecosystem. If you're here, it's because I'm tired. You see, now we have Stack, Next.js. Next year we'll have another JavaScript framework. I don't want to be in that in that thing anymore. Okay. I hope you enjoyed it. I did. I want to back here and here. Now slowly I will prepare the upcoming demo like this. Okay. Hey Julia, we are still here. Thank you. Thank you, Julia. Let's see. Okay. I'm almost ready. Thank you, AstroKernel. Appreciated. Yet, not many people talk about Rust and web development. Everyone is talking about Rust and embedded systems or something else. Kernel, Linux kernels. I think there is so much. If you check my talk of the 5th of January 2024, I mentioned Rust is cool for web development 2 years ago, which is a lot. In software engineering, 2 years is another era. Dinosaurs. I'm happy because I was right. Okay, I think we can go with the demo. Are you ready for the Axum demo? I hope you are. I hope you are. So I already shared a link. I already shared a video about the Axum Hello World. Let's see if I find it. Axum Hello World. I wanted to share this. Share screen. So, oh no. If you go on the internet and if you type Axum Hello World, the first video is mine. Bravo, Francesco. Bravo, Francesco. Try to type Hello World Axum and you will find my video. We made it. Rank 1 on Google. Rank 1 on Google. And today we will make the second episode. Are you ready? Are you ready? So in this first video that we also recorded live because I'm lazy, we made an introduction to Axum. So if you want to check it out, leave a like, share it, that will be cool. Today we'll make the second part. Okay. If you think that this might be useful, share it because I'm still not sure if I'll keep doing this because now we have AI, it can create an Axum server. So I wanted to keep these lessons quite short and I will focus more on the logic, on the understanding, because generating an Axum server, I can do this in 30 seconds. But I want here to stop and today that might also be something that where AI might even fail. Okay? Perfect. Let's do it. I wrote quite a lot of Rust today. I've been talking about Rust for a while. I want to go here. Control B. I want to check. I already have this. Now let's remove this. Okay. Okay. Almost ready. I think let's do it like this. Okay. Are you ready? I want to check how is this. So many people asked me to make bigger fonts. Today I'll make huge fonts. And let's see if I can make you happy. Is this okay? Or even bigger? Is this okay for the font? Or not? I hope it's enough. Okay. Okay. Perfect. Let's do it. Oh, I've been working quite a lot to have this thing. So, okay, nice. Okay. Finally, looks good to me. Perfect. Bigger. Then we complain that we can't read it. Okay. And if I should go at top or the bottom? Maybe I'll put myself here. No. That's it. Okay. So I want to do this. I've been putting some effort in trying to make this as readable as possible. Okay. Are you ready for the second one? Perfect. So let's do this. Just 1 minute break. And then we'll do it. Okay. In the previous lesson, we introduced Axiom and we have done a simple hello world. And we have been focused on understanding how Axiom works behind the scenes. We have used just two dependencies, Axiom and Tokyo. Today, we'll start doing something a bit more complicated, not much, but we will start implementing some user API, some classic user API. We need to add a couple of dependencies. One of them is CERD. What is a CERD? CERD stands for serialization. Deserialization is a crate in Rust that helps you to serialize and deserialize structs, objects. We also need, in this specific case, CERD underscore JSON because we'll have some JSON objects, because when we have to deal with things on the web, usually we use JSON format, usually. Okay, I want to go here, and I wanted to change. This is exactly the code where we stopped last time, okay? And I want to change this code a bit, just to make it a bit less boring, okay? Let's start with the dependencies here. Is this correct? Yes. Dependencies here. So on the routing, we have here get, but I also want to add post in this case, like this. Because I also want to make a post request. We'll make an example. I also want to add an HTTP status code, so we don't have to type the codes for HTTP manually. And also I wanted to talk about extract, because we want to extract maybe some query. Maybe we want the user number 1, 2, or 3, okay? I will check the chat from time to time. No problem, no worries. We need this JSON and then router like this. Okay. Okay, perfect. And of course, we need to import CERD, which is for serialization and deserialization, like this. We can type use CERD. Okay. Now, as you probably already know, here we need a struct. Similar to an object, I would say. Struct. I don't want an item, but I want a user. And this user will have just 3 fields. It can have an ID, a name, and I don't know, an email. We will not make validation in this case. And here also at the top of this struct will have these attributes derived to serialize and deserialize this struct. This is important, otherwise this will not work. Now, let's see. Let's start by typing two additional functions. Okay, so at the bottom of this main function, we'll add what? We'll add basically two handlers. Okay, one is to get users, get a single user by ID, and one is to create a user. Now, today I'm not focused on doing this for real, because for that probably we need a longer session, but I want to focus here on the routing and path and queries. Okay, so we will focus exactly on this. So to get this user, what do we need? Let's see if we get the correct one here. An asynchronous function to get a user, we need this path, so we need to provide the ID here, and we will return something which is in a JSON format, okay? But let's see, this seems correct. We define here a user with an ID, a name, and email. We are not done yet, so this is correct. Here per email, we need user example.com, which is, this is wrong. This is not user ID. Okay, because here I want just to return this as an example. So we are not fetching any DB. We are focused here on this, the path user ID, that is of this type, path U32, and then we return, this is the return type of a function in Rust, okay? And then what? Then we need, this is wrong, we need to return a JSON of the user, like this, okay? Like this. Like this. Async function, JSON user, of course, we need to close this. Okay. I don't know if you are already comfortable with this syntax. Is this clear? What is that? This is similar to type like something like this. Return JSON user with a semicolon. Okay. In Rust, when we have this, we just type this. This is similar to type this, but we type this in Rust. Okay, it's clear. Okay. Okay, so this is to get a user. We are faking to get a user. Of course, this is not a real user. We are just faking it. But this is the parameter, of course. And then another function to fake to create a user. Okay, how can we do this? Of course, we need an asynchronous function to create the user. Here, the important part is this one, is this JSON payload. As you probably might think, we need to provide in the request body of the HTTP request the user we want to create. In this case, we are just providing a whole user. Probably you know that when you create a user, you don't provide your own ID. Okay, in this case, we are just faking it, but this is usually a serial, something serialized, probably using the DB or whatever. Okay, so let's see if this is correct. We are creating a user with email, and we are returning the status code. And you can see here we have the status code created. You probably know which is the HTTP status code for a resource which is created. You can type here in the chat if you know which one is. But maybe I want to return something a bit more complicated, not just this, but I want to return status code created, but I also want to return the user itself. So for example, here we can type the JSON user. So I want to return the user I have already created, even if it's fake, okay? Let me type here. We need to have, and this is, of course, like this. Okay. Status code created. And then JSON payload. Okay. Struct status code. Why this? Status code, payload username, name and email. Let me see. What do we have an error here? Private field. Let's see. What, did I do something wrong? Private field, status code. No. Status code created. It doesn't like it. JSON payload. Bad. It's an example. It's an example. It's an example. Yes. I just don't know why this HTTP status code in FRC. Return is created. Payload username and email with the JSON. Okay. I mean, we can try to run this and see what's the issue. I don't know what's the issue here, honestly. Ah, okay, because it's like this, created. Ah, okay. Status code created. Okay, this is an enum, of course. Okay, and here we add this. Okay, now we are missing something. Of course, here at the top in the main function, we need to add the routes or route if you are from the UK. So let's try to trust AI here. Route user ID and then I think it's users ID. I prefer users. And then route users post. Something like this. And here we need to remove, of course, these. Okay, so we created 3 routes and we have basically just 2 handles because this is the default one. Okay, this is not getting all the users, this is just a default. Okay, so now let's try to compile this. Let's try to run this. Cargo run. Can you see it? Let's see. Have you ever used Axum? Bam. Error. What is this? So I'm not getting any error here, but I get an error here. Do you know the reason? This might not be very obvious. Because I'm not, like, I mean, if I read carefully, I will get a hint. Yes, a lot use Axum. Okay, then we can be friends. Do you know what's the issue here? If you used Axum, probably you know. Let's see. Let's see if you can debug it. Can you? Well, so this is correct. So there is a reason why we should learn Rust, because if we get an error like this, we probably might be stuck for a while and say, oh, okay, Rust is bad. Rust is not bad. It's that the Axum team changed something. They made a breaking change, sadly. So here you need the AI was wrong. This makes me happy. So we are still useful as human beings. Let's try again. Let's see if I made some other typos. And you were correct. It's working. It seems that it's working. Okay. Let's try here. If we try just this, we can try it out. I want to put this here. Okay, here. Okay, let's try it out. Let's try this with curl. Today we'll just do this. Hello world here. Okay, we don't get a new line, but you can see hello world. This was this one. 1 second. Let me just do this. Okay. The other one, let's test a user. let's test a user. We don't need the verbose version. Let's do -v. Maybe we are not returning it. Wait a moment. Because it's users. It's users because I wanted to have users. Let's remove this. Let's try to make a GET request to curl HTTP localhost 3000 users 50. And we have here this fake user. Okay? But here the goal is just to test the handlers. The last test is this one. Let's try to make a fake post request to this. We can have here like this. The URL is users with localhost 3000 users with a post request. And here the important part is that we need to add this header, content type application JSON, and then we provide this ID. This is not username, but is name and email. Okay, let's try it out. Missing field mail. I think that I spelled it wrong. Let's make a post request. I changed the URLs a bit. So it's not email, but it's just mail. Okay, let's do it like this. And we have this fake request. So the goal of this simple example, it was to get used to the third create, which is I think is awesome in Rust. I've been using this since the beginning, since 2024. The HTTP status code, so we don't have to type that manually. This JSON one, the router. This looks very similar to Express. What do you think? Very similar. We have this function. Okay, we don't have the attributes. I think Actix is more similar to Express. The important part is this, because this is in the end what really matters for the web frameworks. How can we pass a parameter, a query param, the type we return? That's it. This is I think that most of us, we already know how to create a web server. Maybe you have created this in Python, maybe in PHP. This is interesting because this is done with Axum. Okay. What do you think? You should try Axum, for real. All the code will be available on GitHub, and see you in the next video. Bye. Perfect. It's a very simple one. We are going really step by step. Probably each Saturday I will add something. I will want to add, maybe I'll also add sessions, JWT. But the cool part is that on each Saturday, I will start from this example and I will improve it. So we'll have also another version of this video in a couple of weeks, I think. The edited version of this. So I'm basically creating the Axum series online, live. Perfect. Amazing. We can go in mode. It has been a long Saturday. So we did the Echokit podcast / demo. Let's say. This is super cool, by the way. Then we made a whole talk and then the Axum demo. So I basically recorded the 3 videos today. Cool. If you want, I can stay 5 minutes, 10 minutes, and then I will leave. For sure, Sebastian, that's a spoiler for the next episode. I don't want to watch a series with you, Sebastian. Yes, of course. Slowly we will do all of them, but I want to keep them like 5-10 minutes. Okay. Did you enjoy it or not? It was a quite long Saturday. And we have been going live for 2 hours and a half. Not that bad. Not that bad. Yes. No, but I'm happy that probably you will get a bit bored, of course, if you already know Axum, but I like the idea that Axum is getting traction in the tech ecosystem. Thank you, Julia. You are the best supporter. You made a question about SQL Alchemy. So it's similar SQL X, but SQL Alchemy is a proper ORM. So it's like a library that does stuff. SQL X is more like a checker. It just checks that you wrote the SQL query, which is better, actually. Because sometimes this ORM, like SQL Alchemy, can add a bit of overhead. It might slow your program a bit. In this case, it just checks if the raw query that you wrote is correct, but then it runs raw queries. So it's way more efficient. Mm-hmm. I don't know if there is something similar for Python. I think because you need a language which is very strongly typed to do this. That it checks at compile time. It will not let you create the program. Still, 2 hours and a half. 2 hours and a half is easy. We recorded 3 videos at Arva live. We did the Echokit example. I recorded the talk, and now the Axum, and also some live coding. If you want me to do more, like the video, share and subscribe. Now, I'm really enjoying these Saturdays when I can, basically I'm recording, like with you. I hope you appreciate this live, and that's it. I'm working, I see a problem here. I want to show you. You see here, Julia, if you share this on the screen, you see I have this weird thing, face fuchsia. I'm trying to fix this. So next Saturday, I might come with a solution for this. I'm studying for a solution to this awful thing. It's horrible. This works. This doesn't work. I'm not sure if I will fix it, but at some point I will. I have no idea what the Ralph Wiggum loop with Cloud Code is. Great. Wrap OBS and make. But now I'm not in OBS because I also had guests. You wish it was that easy at Arva. Maybe I fixed the issue for when I go live alone. I'm also. I can see them because I have the YouTube live event on the side. I'm trying. Give me time. If you give me time, I will fix everything. Is the audio is correct? Did you enjoy it? The only thing is that if I use a Talk Studio, which is similar to StreamYard, maybe the recording quality is a bit lower, but who cares? Just give me time, Julia. Give me time. With the time, I can fix everything. So I hope you enjoyed it. If you have some final questions, otherwise I will just stay like this for 2 minutes just to promote the book. This is worth it. By the way, it's just a reflex, you see. Just the lighting. You see? Okay, I'll just be like this. When is your cloud experience video coming? Looking forward. Yes, I bought the code to yeah. So much stuff to do, but I was already using Cloud Code Opus 4.5 because I have it inside GitHub Copilot. It's funny how Anthropic they are creating a lot of drama with open code, but they are not leaving GitHub yet. GitHub Copilot. I want to show you. We are in relaxed mode now, by the way. No. So let's go back here. So here on GitHub Copilot, did you like this Zen mode or not? So where is the chat? So you see in GitHub Copilot, I can already use it. I don't know if you can read it here. So I use that, for example, for the portfolio, the Cloud Opus 4.5. The sale agents are far more superior than the ID integrated one, at least for now. Okay. I think it depends what you want to build, of course. But I have it. Let's do it. Let's do something with Cloud. No, today no. Next Saturday. Next Saturday, I might actually do something because on the next Friday, I have the bootcamp. I forgot to promote the bootcamp. I forgot. This is the problem when you do too many things at the same time. So on the next Friday, we have the bootcamp. The bootcamp. When is the link? Manage. You see, 350 people signed up. And this is on Friday. On Saturday, I will have another live stream. Probably it will be relaxed because this will be probably the most challenging live stream I ever did. I'm preparing behind the scenes. I hope you will like it. This will be a really hands-on project. Only Julian knows what is this. And that's it. I'm ready for next Friday. You will know this just a couple of hours before, only if you are in the newsletter. I will say this in the newsletter 2-3 hours before the live event, which will be next Friday, 5 p.m. I still don't know if I will do this on YouTube or privately. I'm not sure. But of course, if you are here on this event, we will. This is the link, by the way. If you want, many things are happening. By the way, this is the link. This is the link. I'm using this Luma, which I really, really like it. Perfect. Okay, we are done. So thanks for coming. It has been another cool Saturday live event. Next week, we have the live bootcamp. I don't know if it will be live or a Google Meet. I have to decide. Or it will be on... and then on Saturday, I will still do the live event because that's Saturday. Okay? If I do the bootcamp on YouTube, then we will do something very relaxed on Saturday. Okay? That's it. So, thanks for coming. Really appreciate you showing up. I think I will spend some time in editing. You have some editing to do. Yes. Let's see. Anyway, thanks for coming. Appreciated. Next, I will, and in 2 weeks, I should have the project, the head of the project of the Rust language. Mind blowing. This is the last. I'm trying to get really top guests, top Rust guests on my channel this year. We will see. Okay. Hey, Brahma, you're late. I'm about to close the live event. Okay. Perfect. At some point, I might even do a thread, walking paddle live stream. Maybe next Saturday. Who knows? Okay, perfect. Bye. Bye. It's the recording. It's here. Cloud recording. I've been doing this. I did the whole live event in 480p. I hope that at least the recording is decent. I'm checking it now. Nobody told me about the thing. Let me check the chat. Can you see the difference in the resolution now? I've done the whole live stream in 480p. It will be a hard day. Bye.